guys, welcome back. Throughout this mini series, we have been working with our rational expressions. First, we simplified them, then we multiplied and divided them, then we added and subtracted them, and then no section will be complete or no chapter will be complete without knocking out some equations involving, you guessed it, rational expressions. So the guidelines are typed up. If you have the notes, you can follow along with me, and if not, you can take a screenshot or just listen to my lovely voice. So let's do this. So I'm going to go ahead slide this up, okay, because I'm going to read the notes to you. Okay, so the directions just read solve. So it would be nice if the directions say solve the rational equation, but no. Okay, I need you to be able to recognize what type of equation are you solving. Depending on the type of equation that you're solving, that will determine the strategy that you will use, that you will need to solve it. If you had a linear equation, a degree 1 equation, then you old school it, isolate the variable. If you had a degree 2 equation, then you solve it by factoring. But now, what if you have an equation that has these fractions or these rational expressions? The question is, how are we going to solve them? So first things first, me and fractions don't get along, so we're going to go ahead, work our magic to wipe them out. Before we do, we're going to do this optional prerequisite step. I call it optional, but it's more like optional, wink wink, like do it or else. Okay, so what I recommend then is that you list the restrictions on the variable first. How can we tell if we're gonna have restrictions on the variable? Pretty much, if at least one denominator has a variable in it, then guess what? You're gonna have restrictions on the variable. Go back to that earlier video where we talked about domain. Okay, so the restrictions on the variable, what is that? The restrictions on the variable are the value or the values that make any of the denominators equal to 0. Okay, so we're gonna go straight to answer. I'm not gonna show the work because we're cool like that. So I want to know what are the restrictions on the variable. What can the x not equal in this case? To see what makes the denominator equal to 0, we're going to take each denominator and set that equal to 0. The first denominator, when you set that equal to 0, after you add 2 to both sides, that will give you x equals 2. So we want to tell the world x could be any number except for 2. So we're going to slash it out. Okay, so this is this symbol is read as is not equal to, but when I use this symbol in conjunction with the word restriction, I read it as can't. X can't equal 2. What else can x not equal? So I'm going to go ahead, look, I'm going to skip this denominator temporarily. I'm going to go ahead, look at this denominator, set that equal to 0. After we subtract 2 from both sides, that will give us x equals -2. So we want to tell the world x cannot equal 2 or -2. Because remember, if x equals 2, when you plug it in, I'm going to focus on the bottom. 2 minus 2 is 0. The quotient of something as 0 is undefined. If x is -2, -2 plus 2 is 0, and quotient of 1 and 0 is undefined. What else makes a denominator equal to 0? Let's go ahead, factor this bad boy. Okay, we got a binomial minus, and this will factor to a difference of squares of the form x plus 2 times x minus 2. Okay, so I forgot to do my mold. Sorry. Let me turn this off. I'm playing with the lights. Okay, so I have a little romantic setting. All right, so let's do this. So we know that 2 or -2 makes at least one of the denominators equal to 0. What else makes a denominator equal to 0? So let me go ahead, look at this bad boy. When we take this product, set it equal to 0, the first factor, we already talked about it. The second factor, we already talked about it. So we actually listed all the restrictions on the variable already. Now, bear in mind that the directions just read solve. It doesn't say list the restrictions on the variable, but because we're overachievers, pretty much we want to make sure that we don't get dinged for being what's the word that I'm trying to say? I'm gonna rephrase it. The worst thing you can do to yourself is pretty much like do all the algebra correctly, but you still get it wrong because you failed to watch out for restrictions on the variable. Okay, I've said too much. Next time, remind me to start working on the problem, and then I can send my speech. Okay, so how do we solve rational expressions? Step 1, it's more like an optional, but do it, okay? List the restrictions on the variable, if any. Step 2, work your magic to wipe out the fractions. Okay, how? You're gonna go ahead, identify the LCD, and then multiply both sides by the LCD. But with your permission, let's go ahead, rewrite the equation so all the denominators are in factored form. Okay, so that will give us x over x minus 2 is equal to 8 over x plus 2 times x minus 2, and we're gonna subtract from it 1 over x plus 2. Okay, to find the LCD for a set of polynomials, 1, we gotta make sure that all the polynomials are in factored form, and then 2, we're gonna multiply the different factors using the biggest exponent on each factor. All the polynomials are factored, so let's do this. We don't have integer factors, we don't have variable factors, all we have are binomial factors. So let me go ahead, list the LCD. So let's multiply all these different factors. We got an x minus 2. It's recycled elsewhere, but either way, the biggest exponent on it is 1. So let's go ahead, put that in our multiplication list. A different binomial factor that I see anywhere is the x plus 2. It's recycled elsewhere, and either way, the biggest exponent on it is 1. And I believe that's it, because I don't see any other factors, okay? Any other different factors. So let's go ahead, work our magic, wipe out the fractions by multiplying both sides by the LCD. So we're going to multiply the left side by LCD, multiply the right side by the LCD. On the right side, I have like all this space. On the left side, I don't think I can easily fit these binomials, so I have options. Option 1, write it really small, or option 2, just write it however I can. Okay, so I'm gonna write this x minus 2, and I may you know what, I'm gonna squeeze it. Yeah, okay, if you have no space, you could write it like a diagonal or something. Okay, do what you gotta do. Okay, let's take our time, see what we get, and then again, the purpose of multiplying both sides by the LCD is to get rid of the fractions. Once we take our products, once we distribute, if we still have a fraction left, then check your LCD because it's wrong. Okay, oh, no negativity, sorry. Okay, so on the left side, the x minus 2 should cancel, and it does. Let me go ahead, slash it out, and that will leave us with x times x plus 2. Okay, let's do this. X times x plus 2 equals, on the right side, we have to distribute, so I highly recommend you don't use your cross-canceling notation. Okay, LCD times the first rational expression. Remember, the denominator is supposed to cancel, so the x plus 2 is supposed to cancel, the x minus 2 is supposed to cancel, and we do, and that will leave us just with 8. Okay, operation minus LCD times the next rational expression. Remember, we're trying to wipe out the fraction, so the x plus 2 is supposed to cancel, and that will leave us just with x minus 2 times 1. Okay, do you need the 1? No, I just do it for dramatic effect. So at this point, I'm like, oh yeah, we did it. Okay, cool, fractions are gone. Let's just use our skills from back in the day, you know, from kindergarten. All right, so on the left side, let's distribute that x. X times x will give us x squared. X times 2 will give us 2x equals 8. Let's go ahead, distribute that -1. That doesn't look like a subtraction sign. Sorry, I got nervous. -1 times x will give us -x. -1 times -2 will give us 2. Fantastic. Let's go ahead, continue to clean the right side. So we have x squared plus 2x is equal to, we have one variable term, let's bring it down, and the sum of the constant terms, namely 8 and 2, will give us 10. Cool. So again, we started with a rational equation, so an equation with rational expressions. Now we have a degree 2 equation, or quadratic equation. How are we going to solve it? Yeah, you said it, by factoring. So let's do this. Sorry, I need some water. So if we solve a quadratic equation by factoring, the first thing we need to do is set this bad boy equal to 0. So let's go ahead, add x to both sides, and that will leave us with x squared plus 3x is equal to 10. Okay, to finish it off, we want to write it in, we want to set it equal to 0. Let's go ahead, subtract 10 from both sides, and that will leave us with x squared plus 3x minus 10 equals 0. Remember, we have said that we want to solve this quadratic equation by factoring, okay? So our first step is to set it equal to 0, and then we can factor completely. Prerequisite step is to watch out for common factors. We don't have any. We got a trinomial, and you know my speech, and if you don't, I'm crying, because that means you haven't watched my earlier videos as I asked, okay? Trinomial, is the leading coefficient 1? It sure is. So that means we don't have to use the AC method unless you really want to. Okay, let's go ahead, throw down parentheses, work on getting the product of the first term. So we'll use variable times itself. To complete the binomial factors, we want factors of c that add up to b, factors of -10 that add up to 3. I believe there's a 5 and a 2 where the larger factor is positive. So let me check it. Product is -10, sum is 3, so we're good. Someone said, what happened to the x game? I didn't feel like writing it, you know. If you need it, go for it. But if you don't need it, then I don't need it. But, you know, I'm nice. I'm going to do the x game. So the x game, we want factors of c that add up to b. Factors of -10 that add up to 3. You know, and I had set 5 and -2. You can switch the sides. Cool. Remember, for our equation, our new equation, our quadratic equation, we are solving by factoring. So step 1, set it equal to 0. Step 2, factor completely. Step 3, apply the zero factor property. So if a product equals 0, there's no way around it. One of these factors has to equal 0. Either the first or the second factor equals 0. Okay, so either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, that's going to lead to a proposed solution of x equals -5. If the second factor equals 0, that's going to lead to a proposed, and I'm going to tell you why I say proposed. Oh, sorry, I slashed this by mistake, okay? If the second factor equals 0, then that's going to lead to a proposed, I need to enunciate, a proposed solution of x equals 2. The reason why I say proposed solution versus just solution is because we have restrictions on the variable. We had told the world x could be anything except for 2 or -2. Okay, it's a shame that I can't project it with what I have. X could equal anything except for 2 or -2. So 2 cannot happen. Okay, you want to impress your friends, you tell your friends that 2 is an extraneous solution. Extraneous solution. You don't have to write this for credit, but you know we're overachievers, so we're gonna do it for notes. What's an extraneous solution? An extraneous solution is pretty much a solution of one of the new equations, like one of the resulting equations, but it's not a solution of one of the original equations. So what's going down? We had 2 possible answers. One couldn't fly. We still have something to go by, so the solution is just -5. Okay, I checked it at my house. Cool. So we're gonna go ahead do 3 problems. That's our first problem. I got 2 more. Bear with me. Okay, so let's go ahead and solve this bad boy. So I'm like, okay, what kind of equation is this? All right, we have fractions in there, so we have another rational equation. Am I going to have to list restrictions on the variable? I don't know. Does at least one denominator have a variable in it? Unfortunately, the answer is yes. So we're going to list restrictions on the variable. I think what I'm going to do first, I'm going to make sure all the denominators are factored, and then we're going to list the restrictions. First denominator, there's nothing to factor. Second denominator, there's nothing to factor. Third denominator, oh yeah, that one is not quite a winner. Prerequisite step is to watch out for common factors, but these terms and these terms have a common factor of x. Sorry, I'm distracted with the background noise. When we factor out an x, that will leave us with x minus 6, and that's it. Just by taking out the GCF, we have factored completely. Let's write our new equation. Okay, well, let's rewrite the equation where all the denominators are in factored form. So we have x minus 2 over x minus 6 minus 4 over x is equal to 24 over the freshly factored x times x minus 6. Fantastic. Remember, the directions just read solve. It doesn't say solve and list the restrictions. But check it out. I'm going to go ahead and project our earlier problem. The reason why I think it's, I don't want to sound dramatic, but the reason why I think it's vital to list the restrictions like right now, like at the beginning versus later, is that if you're like me, if you don't list the restrictions when you're like nice and fresh, after all this algebra, it's like, man, like I'm exhausted. Okay, I think after all this algebra, I would be like, oh, I'm so excited, we nailed it. I don't think I would have the energy to think about like, oh wait, I gotta watch the restrictions on the variable. Okay, so this is my recommendation. If you are solving a rational equation, love yourself, and although you don't have to because the directions don't say, love yourself, and although you don't have to, list the restrictions first, and then after all that mental workout, then you can check your answers against the restrictions. Okay, that's the last time I'm gonna say that. Okay, so in this case, let's go ahead, list the restrictions on the variable. So we want to tell ourselves what the variable cannot equal. So I want to know what makes any of the denominators a 0. When you take the first denominator and set that equal to 0, after you add 6 to both sides, that will give you x equals 6. So we want to tell the world x cannot equal 6. Another denominator. Okay, what makes this denominator a 0? When you take this denominator and set that equal to 0, that will give you x equals 0. That's it. There's nothing to solve for. X equals 0. What else makes a denominator equal to 0? We got a product, so let's go ahead, set each factor to 0 one at a time. First factor, set equal to 0. We already talked about it. Second factor, set equal to 0. We already talked about it. So the restrictions are that x cannot equal 6 or 0. And I want to make a big fuss. If needed, we can even say watch out. Okay? Do what you gotta do to bring attention to this. Okay? So now, me and fractions don't get along, so let's go ahead, wipe out the fractions. So let's go ahead, identify the LCD. So we're gonna multiply, we're going to take care of the integer factors, variable factors, and binomial factors. We don't have integer factors, but we do have variable factors. So let's do this. So we're going to multiply the different variables using the biggest exponent on each variable. The first variable that we see is the x. It's recycled elsewhere, but either way, the biggest exponent on it is 1. Now, let's look at the binomial factors. The first binomial factor that we see is x minus 6. It's recycled elsewhere, but either way, the biggest exponent on it is also 1. So let's go ahead and put it in our multiplication list. Remember, LCD for polynomials, multiply the different factors using the biggest exponent on each factor. And I said it before when we were adding and subtracting rational expressions. Finding the LCD is like one of the toughest things, Once we have that, we just keep our cool, make sure we don't mess up on arithmetic, and then we're good. Okay, so let's go ahead and wipe out the fractions by multiplying both sides by the common denominator just found. So we're gonna multiply the left by, what is it, x times x minus 6, and we're gonna multiply the right side by x times x minus 6. So someone had asked me, why is it that I use brackets instead of parentheses? The reason why I do that is because I already have parentheses in there, so I don't want like the same grouping symbol. Okay, so let's go ahead, distribute, and confirm that the fractions are gone. Now, Common denominator times the first rational expression, the x minus 6 is supposed to cancel, okay? And that will leave you with x times x minus 2. LCD times the next rational expression, the x is supposed to cancel, and that will leave you with x minus 6 times 4. Well, let's drop down that negative, okay? So that will leave us with x minus 6 times 4. But to make it aesthetically pleasing, we'll put the 4 and then the x minus 6. Okay, on the right side, there's no distribution. You know, distribution means you multiply over addition or subtraction. On the right side, there's no distribution, so let's go ahead slash things away. The x is supposed to cancel, and I say supposed to because we're trying to wipe out the fractions. The x minus 6 is also supposed to cancel, and that will leave us just with the numerator of 24. So fantastic. So we have a few ways to go, but we got this. We got this. Okay, remember that. On the left side, let's clean it up. When we distribute the x, that will give us x squared minus 2x. When we distribute the negative 4, that will give us negative 4x plus 24. On the right side equals 24. Fantastic. Let's go ahead, continue to clean up the left side, and then we'll make a strategy in terms of how to solve it. So that will leave us with x squared, negative 2x minus 4x will give us negative 6x, and we bring down the rest of the problem. Cool. So then I'm like, okay, what kind of equation do we have now? We have a degree 2 equation or quadratic equation. How are we going to solve it? We're going to solve it by factoring. So to solve by factoring, set the equation equal to 0, factor completely, and then apply the zero factor property. Let's do this. To set this equation equal to 0, let's go ahead, subtract 24 from both sides. And that will leave us with x squared minus 6x is equal to 0. Okay, so it's set equal to 0. Now that we set the equation equal to 0, we have the green light to factor. Okay, prerequisite step is to watch out for common factors. When we factor out an x, that should leave us with x minus 6. And if you're having a moment, check it right now, distribute, and then you'll get the right answer. So we got a lucky break that in the sense of just by taking out the GCF, we factor completely. At this point, we have that the product equals 0, so let's apply the zero factor property. If a product equals 0, then one of these factors has to equal 0. Either the first or the second factor equals 0. So let's do this. Either the first factor equals 0 or the second factor equals 0. I don't know how to write. I should sleep. Okay, bad things happen when you're not sleeping. Okay, so either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, then that's it, we nailed it. Okay, if the second factor equals 0, then that will lead to a solution. I have to say proposed solution of x equals 6. Okay, or I'll say possible because it's easier for me to say. So our possible answers are 0 and 6. Now I gotta say real math, okay? Our proposed solutions are 0 and 6. But what did we say in the beginning? We had told the world, watch out. X could equal anything except for 6 or 0. Remember those numbers. X could equal anything except for 6 and 0. X could equal anything except for what again? 6 and 0. Do you have to slash these things out? Absolutely not. Absolutely not. You just have to box your answer. But if you're like me, if you don't cross it out, you're going to box them by mistake. So what is going on? We had two possible answers. Neither one could fly. Since we have nothing else to go by, then there's no solution. Why is there no solution? Because look, there's no answer. Okay, we have nothing to go by. Okay. So both of these are extraneous solutions. Something that I want to point out is this. Just because you have an extraneous solution, it doesn't mean that that the equation has no solution. Okay, we write no solution when we have nothing to go by. The first problem that we knocked out, we had two possible answers. One couldn't fly, but we're not going to write no solution. Why not? Because we have a solution. It's -5. Or in English, we're not going to write no solution because we have something to go by. The reason why we put no solution in B is because we have nothing to go by. Okay, so there's no answer. Okay, guys, so I said we were going to do 3 problems. This is our second one. Let me go ahead and hunt our third problem. Okay, guys, so our third problem has been hunted. So let's go ahead and do this. So again, when it comes to solving equations, we need to identify the type of equation that we have, because that will determine the strategy that we're going to use to knock it out. We have an equation with fractions or rational equations. Let's do this. So let's go ahead and make sure that all the denominators are in factored form. So we're cool with the first 2 denominators. It's the third one we have an issue with. Binomial minus, and if you keep your cool, we have a difference of squares. So this should factor to x plus 1 times x minus 1. And if you're having a moment, FOIL it out, and then you can see you have back your x squared minus 1. Let's go ahead and rewrite the equation so all the denominators are in factored form. We got 2 over x plus 1 plus 3 over x minus 1 is equal to 5x plus 1 over its freshly factored denominator of x plus 1 times x minus 1. Cool. So I said it before, you don't have to list the restrictions on the variable, but look at what has been happening at the problems that we've knocked down. Okay, so love yourself, just list them. Okay, so what are the restrictions on the variable? What can the variable not equal? Okay, so pretty much we don't want the denominator equal to 0. So we want to know what makes the denominator equal to 0. If we take the first denominator and set that equal to 0, after we subtract 1 from both sides, that's going to give us x equals -1. So we want to tell the world x could equal anything except for -1. Cool. What else makes another denominator equal to 0, or any other denominator equal to 0? Let's look at this bad boy. X minus 1. If we want to know what makes it a 0, then we set it equal to 0. When we set it equal to 0, after we add 1 to both sides, that's going to give us x equals 1. So we want to tell the world x could equal anything except for -1, +1. Now, what else makes another denominator equal to 0? We have a product. When we set that equal to 0, we set each factor equal to 0. First factor, x plus 1, is been dealt with. Second factor, it's already been dealt with. So that's it. Okay, we have listed the restrictions on the variable. And I love myself. I don't want to do all the algebra, but get dinged because I failed to check my answers against the restrictions. Okay, so let's do this. We're going to work our magic to wipe out the fraction. So let's identify the LCD. We don't have integer factors, variable factors. All we have are binomial factors. So we're going to multiply the different binomial factors using the biggest exponent on each binomial factor. The first binomial factor that we see is the x plus 1. It's recycled elsewhere, but either way, the biggest exponent on it is still 1. So let's go ahead and put that in our multiplication list. A different binomial factor that we see is the x minus 1. It is recycled elsewhere, so let's but either way, the biggest exponent on it is 1. So let's go ahead and put that in our multiplication list. Okay, I think we knocked them all out, so we're good. We're going to wipe out the fractions by multiplying both sides by the common denominator just found. So let's do this. Multiply the left by the LCD. Multiply the right by the LCD. I don't think I could squeeze in the x plus 1, x minus 1. So it's going to be really weird. But you know what? When there's no space, there's no space. I guess my other option is just to erase everything and indent, but who has time for that? Not I. Okay, so if you run out of space, it's okay. I can see that you ran out of space. Okay, let's go ahead, distribute or multiply and confirm that the fractions are gone. So let's do this. LCD times the first rational expression, the x plus 1 has to cancel. And I say has to because we're trying to wipe out the fractions, okay? The x plus 1 has to cancel, and that will leave us with x minus 1 times 2, or 2 times x minus 1. LCD times the next rational expression. Let's go ahead and bring down the operation. The x minus 1 has to cancel, and that will leave us with x plus 1 times 3, or 3 times x plus 1. 3 times x, oh, what was it? I need my fingers. 3 times x plus 1. On the right side, there is no distribution, so you can use your cross-canceling notation if desired. The x plus 1 has to cancel. The x minus 1 has to cancel. And that will leave us just with 5x plus 1. Okay, these are like the weirdest ones. They don't even look like ones. Remind me not to use a highlighter again. Okay, so that will leave us with 5x plus what? Fantastic. Let's clean up the left side and then see what strategy we're going to use to solve. Is it a linear equation? Is it a quadratic equation? So on the left side, when we distribute the 2, that will leave us with 2x minus 2. When we distribute the 3, that will give us 3x plus 3 equals 5x plus 1. Let's keep our cool and handle it. On the left side, when we combine the variable terms, 2x plus 3x will give us 5x. When we combine the constant terms, negative 2 plus 3 will give us 1. Okay, and this is where me and your book fight. Okay, so the books typically say, quick, what's the answer? But then I'm like, I feel like that's like a premature question, okay? Because we are solving for x, and the x has yet to be isolated, so I don't feel ready to make a call. So let's just do what we do, okay? So now I'm like, okay, what's the degree? The biggest exponent on any of the variable terms is 1, so we have a linear equation. Let's old school it. We want variables on one side, non-variables on the other. Let's go ahead and move that 5x. Which of the two? Whichever one you pick, that's the one I'm picking, okay? No one's gonna know if it was the left or the right, okay? We're both gonna subtract 5x. So when we do, the x's cancel out on one side, and the x's unfortunately cancel out on the other side. So my natural reaction, it's not my reaction, I'll just say the truth. Students sometimes like to subtract 1 from both sides because for whatever reason, but check it out. We were not solving for 1, we were solving for x. So as soon as the variables cancel out, I need you to stop right here. But if you subtracted 1, that's fine, okay? No matter what section you're in, if the variables cancel out, I need you to ask yourself this very important question. Do I have a true or false statement? Okay, do we have a true or false statement? I'm like, I don't know. Does 1 equal 1? Yeah, it sure does. Okay, so I'm going to circle it. Okay, since the variables canceled out and we ended up with the true statement, and that means that the solution is given by the set of all real numbers. And I want to box those words, you know, all real numbers. But remember in the beginning that we had some restrictions on the variable. We had said world, x could equal anything except for -1 and +1. So the solution set is given by the set of all real numbers with the exception of those restrictions. So I'm going to write a little note to myself. All real numbers, but x can't equal -1 or 1. Now the question is, can we box this for credit? No, it doesn't. Why? Because it's not good notation. Okay, if it was a verbal quiz, yeah, I'm like, what's the answer? And you tell me, oh, all the real numbers except for -1 and 1. I'm like, bam, full credit. But it's not a verbal test, so we need to have good notation. The directions don't specify how to write the answer in this case, but we're just going to go with interval notation, okay? You can use another notation if desired, okay? So now, for me, it's really hard to just say all real numbers except for -1 and 1 and then say, bam, this is the interval. I'm going to have to graph it, okay? What am I going to graph? I'm going to graph the entire number line with the exception of these two bad boys, okay? So we're going to graph the entire number line with the exception of those restrictions, with the exception of -1 and +1. Okay, what are we graphing? We are graphing the entire number line. Okay, so the solution is pretty much given by the values that are under -1, the values that are between -1 and 1, and the values that are greater than 1. Okay, so we have that the first interval is given by -infinity to -1, where -1 is excluded. We got another interval, and we're too cool to say the word or, so we're gonna use the union symbol. Remember, we use the union symbol when we have interval notation and when we have more than one interval. What else is in the solution? Oh, it's the numbers between -1 and 1, where both endpoints are excluded, which is code for parentheses on both. Another interval, so we have union. So the interval is given by 1 to infinity, where 1 is surprised, also excluded. Why did we write our answer in interval notation? Well, that's because that's the only way that we can write the set of all real numbers with the exception of these bad boys. Okay guys, so I said we were going to do 3 problems. That's our third and final problem. We're out. Thanks.